This is Suck, and in this video we are looking at integration. So integration is the reverse process of differentiation, and therefore you add 1 to the power before dividing by the new power. And we looked at differentiation in the last few videos. And you should also add a constant, which is c, when you integrate anything, and this is known as the constant of integration, and it allows for any constant that differentiates to give nothing. For example, if you were to differentiate 24, for example, that would give nothing. That is why you're adding that c to allow for it. So first of all, we will integrate 4x squared plus 4x minus 28, and at the end of integration you always have dx. Now, in order to start this, if we are integrating 4x squared, you're going to add 1 to the power, so therefore you'll have cubed, and then you're going to divide by the new power. So therefore that would go to 4 over 3, and the new power is x cubed. And you can check this, because if you were to differentiate 4 over 3x cubed, you would get 4x squared. So the next one, we're going to add 1 to the power to make that squared, and then we're going to divide it all by 2, so that will be 2x squared. The next one is a lot easier, as there is no x already, so all we're going to do is basically just make it so there was an x, and you can just think about differentiation here, and minus 28x would just go to minus 28, so you can work in that way. But to finish off, we're going to have to add this constant. Never forget the constant, because it's very easy to forget this, but that is again the constant of integration, and you have to do that with all things unless you can work out what c is, and we'll look at that slightly later on in question 3. So the next one, a similar sort of question, but just slightly more difficult numbers. So I'm going to rewrite this one. So obviously we've got 3x squared, that will stay the same. But minus 1 over the root of x cubed, you can make that minus x. And then because it's 1 over, it will be a minus. And then this here, the root of x cubed, it would actually be x to the 3 over 2. So therefore you can do minus x to the minus 3 over 2. And that's because you're square rooting it, but you're also cubing it. So that's why it's going to be 3 over 2. So then if we're going to integrate this particular thing, so the first one's very easy to integrate. You're adding the power by 1 to make it 3, dividing by 3, therefore you've just got x cubed. And then the next one, this one's slightly harder to integrate, but it will go plus, because what you're going to do is do minus 3 over 2 plus 1, which goes to minus a half, and then minus a half times by minus 1 is equal to 2. So that'll be plus 2, then we've got the x, and then we've got the minus a half. And again, just have to remember to plus the c at the end. Now this one is slightly more difficult in the way that we have to start working out what c is, but again it's not overly hard. But first of all, we're going to integrate the 5 root x, which I'm just going to write as 5x to the half. And again, with both differentiation and integration, it's always good to write them in different forms to make them easier. Now then this will go to, so we'll do a half plus 1 goes to 3 over 2, and then do 3 over 2 times by 5, that's going to be 10 over 3. So 10 over 3 x to the 3 over 2. And then obviously you have to have that plus c. But this is where you can start using this extra information that you have to start working it out. And we already know that this will be x here, and that one will be y. So therefore, you're just going to put them in, because y is going to be 100 there, so 100 is equal to 10 over 3 times by 9 3 over 2. And then that's going to be plus c. Now if you work out what 10 over 3 times 9 to the power of 3 over 2 is, you can work out that that is 90. So therefore 100 is equal to 90 plus c. Simple rearrangement means that c is equal to 10. So therefore, you know that that is equal to, if you're looking back at the original one here, it's exactly the same as that, but we could just add 10 for c, so 10 over 3 x to the 3 over 2 plus 10. And that is your final answer for that one there, where you can work out c. So now it's time to put this into a little bit of context, and for this we need to know the relationship between displacement, velocity and acceleration. So displacement, which is also known as kind of distance, can be differentiated to give velocity, and velocity can be differentiated to give acceleration. Now this means that integration is just the other way around, and acceleration can be integrated to give velocity, and velocity can be integrated to give displacement. So I thought if we're looking at a question which is more of a context which involves differentiation, this one says a particle moves on the x-axis so that its acceleration is a function of time, a to the t is equal to 2t. That means that acceleration in terms of time is equal to 2t. And initially the particle was 2 centimeters to the right of the origin. That's giving displacement, traveling with a velocity v of 2 centimeters per second. So that's giving the velocity. So what we have to do is express displacement and velocity as a function of t. So we'll start with velocity, v there, and we know that velocity is just going to be, as seen from this, acceleration integrated. So therefore we're going to integrate 2t. And 2t integrated is fairly easy. Again, we're going to raise that power by 1 to get t squared, and then divide 2 by 2. So that's just going to be t squared. But then remember, plus c. Now, this isn't finished yet because we do have more information, as we know that velocity is 2 centimeters per second. So therefore we can work out what c is. Now therefore 2 is equal to t squared plus c, but we also know what t is. And this is the importance of reading the question fully, and initially is the important word here, as we know that by saying initially, it means that at the start, and at the start it means that time must be 0. So therefore we can denote that t is equal to 0 at the start, and that's because this is all happening at the start. So therefore 0 squared plus c. So therefore c is equal to 2, and we know that v is there, is equal to t squared plus 2. So then if you want to work out what the displacement is, which displacement actually says s, then what we can do is just integrate the velocity. So we're going to integrate t squared plus 2. And that's going to go equal to, so 2 plus 1 is equal to 3, so that would be 1/3 t cubed and then The 2 will just go to 2t. As we know, that's one of the easier examples when it's just a number. We'll always just add whatever needs to be added. And then don't forget the plus c at the end. And again, this is where we're looking at, was 2 centimeters to the right of the origin. Therefore, we know that we can work out c. So 2 is equal to, and rather than writing it out, we know again that t is equal to 0. So this is just going to cancel, and that's going to cancel there to give just 2 is equal to c. So therefore, we know again 2 is equal to c, so that s is therefore equal to 1/3 t cubed plus 2t, and then plus the constant, which is in this case 2. So that's 2 examples of integration using more of a context, and where you have to think about the relationship between displacement, velocity and acceleration, and this will often come up in an exam. So thank you for watching this video, and see you soon. Bye.